Now that you all have a better understanding of what temperature is, what thermal energy is, and what heat is, and how they're similar and different, we're going to move into the phases of matter and see how all of these things apply to them and get a better understanding of molecularly what's happening to each of those.
Your goals for this video are to do two things. Identify the phases of matter. And for this purpose, or for this video, there's only going to be three. There is a fourth one, which we are going to talk about down in class. That's why I've blocked it off for now, called plasma. But we'll come back to that in class. And be able to describe the behavior of the atoms and molecules in those phases as it changes from one phase to the next. When molecules have very little thermal energy, and therefore little temperature, they slow down and are able to get much closer together. When that happens, occasionally, what you'll get is the formation of what's known as a bond. And a bond is what these lines represent right there. Two atoms or two molecules are going to be connected. In this phase, we call it a solid. Solids hold their shape, and they do something called not flowing. Liquids don't have bonds, so what happens is the molecules are free to move around as they please. They are able to flow. So what does it mean to flow?
On the right, I have some liquid water, and on the left, I have a solid rock. How about you guys tell me what you think flowing means? Take a look at the liquid water. I missed. And what about the solid rock? I don't think that flowed pretty well. With gases, molecules and atoms are moving at their absolute fastest, at least for now as far as we're concerned. And like a liquid, it can expand and contract and fill a container, so it also is able to flow. But unlike a liquid, it doesn't hold its volume. So what does that mean to hold its volume? Here we have some liquid water again. Ignore the spill, whatever. And you can see if you read the side that it has an approximate volume of about, and you're going to read the right side of this, 125 milliliters. So by holding its volume, I mean that if I were to move this around and move it into something else, this time without spilling, you can see it's going to have the same volume. It's not really going to change. The molecules are contained within this amount. Gas, on the other hand, well, that's kind of hard to show you because the molecules are so far apart, but here's the atmosphere all around us. It's constantly expanding and contracting and not holding the same volume that it's within. So the phase of matter all depends on what the molecules or atoms are doing. So for a solid and liquid, for instance, these are both able to hold their volume, whereas the gas cannot. On the other hand, as far as flowing goes, both a liquid and a gas can flow, but a solid cannot. And we know that it's going to come down to how much thermal energy all of these has. Which has the most and which has the least? Well, what do you think? Which one has the greatest kinetic energy? The gas. So here we're going to have the most, while down here with the solid, we have the least. If you guys have an extra moment, go to this website. I've included a link at the bottom of the YouTube video in the description. When you go to it, click on the simulations button right here on the right side of the page, and it'll open up something that looks like this. Not exactly like that, but something like this. And go down to chapter 4 and look at the motions of atoms in a solid, a liquid, and a gas. Watch those videos. They'll be very helpful. They're very quick, very short. Let's put this into perspective now with temperature, thermal energy, and how it affects the molecules. So this right here is representative of, say, some solid. In actuality, a solid would never contain only 4 little molecules. It could. But usually it's going to contain a lot more than this. But we know that a solid has the least amount of energy. but it's still going to be vibrating a little bit. So this is kind of what the solid might look like if you looked at it at molecular level. If I were to start heating this, remember heat means adding thermal energy from something hot to something cold, it's going to start to increase the jiggle. And what will happen is as the jiggling gets more and more violent, these bonds will start to break. And it'll turn into a liquid. And it'll start to flow around. And as you keep heating it, it'll keep breaking all of these bonds until every last bond is broken. And you're left with a bunch of molecules that are now just jiggling, just like that. And if I kept heating it after a while, they would start vibrating so violently that they start shooting all over the place because now it's in the gas phase. And that's what's happening on the molecular level when you're adding thermal energy and increasing the temperature of these different phases. We're going to stop on that for now, but in the next few days in class, we're going to explore exactly what's happening with temperature as we change from phase to phase to phase. So I'll see you all in class.